All right, so we have a fun little word problem to start us off here. So I want you to do 1A and B together with your partners. Go ahead, 1A and B together with your partners. All right, so 1A says, Chloe and Charlie are taking a trip to the pet store to buy some things for their new puppy. So let's think about what they're buying. They need to know, or they know that they need a bag of food, which costs $7. How many bags of food do they buy? Just a single bag of food for $7. So that's 7. Plus, what else do they buy? They also want to buy some new toys. They find a bargain barrel containing toys that cost $2 each. Write an expression for the amount of money they will spend if the number of toys they buy is T. So I know that toys are $2 each times how many toys are they buying? T, right? So I have 7 plus 2T. That's my expression for them spending money. And then it says Chloe has $30 and Charlie has 1/3 of that. So how much does Charlie have? $10, right? Charlie has $10. So how much money do they have total? $40, right? So I have 40. And I want to compare that total amount of money they have, which is 40, to the way that they spend money, 7 plus 2T. So let's think about this. I want you to have a quick conversation with your group. Do you want or do they want their money to be more than the money that they're spending, or do they want the money that they have to be less than what the money that they're spending? Go ahead. I'm hearing lots of wrong answers. I'm hearing lots of wrong answers. You gotta think about it. Okay, so let's think about it together here. The money that is in my pocket, the money that's in my pocket, let me explain a little bit more. The money that is in my pocket, do I want that to be more or less than my bill, the money that I'm spending? You want the money in your pocket, which is the $40 for them, to be more than what they're spending. Sorry, that kind of looks like a 7. Let me redo it. So I want 40 is greater than 7 plus 2T. Let me ask you this question. Could the money in their pocket be the exact same as their bill? Is that okay? Yeah, so what do I need? What kind of sign do I actually need? Greater than or equal to, right? So I want 40 to be greater than or equal to 7 plus 2T. Or I could have it this way. 7 plus 2T. So their bill is less than or equal to the money they have in their pocket, which is 40. So it doesn't matter which way you write it. Excuse me. It doesn't matter which way you write it. Just take one of those, and now we're skipping number 2. So take one of those two inequalities, whichever one you wrote, and now solve it on number 3. Go ahead. All right, so it says there, Charlie, remember they can use algebra to solve the inequality just like you solve an equation, right? Almost every, like 99% of the steps that you use to solve an equation, you also use to solve an inequality. So I go ahead and find my equal sign just like I would, or find my inequality sign just like I would the equal sign. And now what would be my first step in solving this if it were an equation? Yeah, Sophia? Good, I would just subtract 7 from both sides. Remember, an opposite operation to go opposite sides of the inequality sign. So 40 minus 7 is 33. Is greater than or equal to 2T. I divide by 2 on both sides just like I would in an equation. And I get, what's that, 16.5? Yep. Is greater than or equal to T. Okay, over to the side of that, I now would like you to quickly interpret that. Interpret that. So realize that this interpretation is going to be a little bit different than we would with an equation, right? So I want you to try to interpret it together with your partners, and I want you to, you're going to have to write a sentence for this one, okay? You will have to write a sentence for this one. You can't just say 16.5 toys, okay? You're going to have to write a sentence for this one, so go ahead. Okay, so does somebody want to be brave and give me their answer? Called you out on the bravery. Okay, Isabel? Okay, is the number that we found a money value? No. Okay, so that was a good try. Somebody else want to be brave and try? Okay, Eliza?
You can buy 16 toys because you can't buy like 16 and a half.
Okay, you can't buy 16 and a half, so you can buy 16. That's getting a lot closer. But remember, we can't just say this is an equation, right? This is not an equation. All right, Cassidy?
I said they can buy a maximum number of 16 toys.
Okay, so you could say a couple different things. You could say they can buy a maximum of 16 toys, or you could say they could buy 16 or fewer toys. Could I say they can buy fewer than 16 toys?
Yes.
You can say it. It's true, but it's not 100% true. Because if you say they can buy fewer than 16 toys, that implies that they cannot buy 16 toys. You follow me there? Saying fewer than 16 is not quite 16 or fewer. You could say they could buy fewer than 17 toys. Probably the easiest way to explain it is just what Cassidy said. They can buy a maximum of 16 toys. It's probably the easiest way and the best way that it flows in the English language, okay? All right, good. Let's flip over to the next page or scroll down or whatever you do. Okay, we're going to skip 4. I want you to do 5 and 6 together with your partners. 5 and 6 together with your partners. Go ahead. Okay, you can go ahead and check your answer on the board. Remember, we need to make sure and have a closed dot at 16.5 because it is equal to. Remember the difference between an open and a closed dot? Open means it's not equal to. Closed dot means it is equal to. And then on our inequality, x is smaller than or equal to 16.5. So I shade back to the left as smaller than. On number 6, the mistake made was going from line 2 to line 3. They should have used an opposite operation to subtract 5 from both sides, but they added on both sides. Okay, so a quick little error analysis problem there for you. Okay, any questions on 5 and 6? Okay, so looking at 7, okay, or no, I guess not quite 7. We're up at the top, or up above 7. It says, Chloe liked the fact that Charlie's method work for solving inequalities did not involve guess and check. So she asked him to show her the method for the inequality negative 2x minus 4 is greater than 8. Charlie showed Chloe the work below to solve. So this is work that he showed. And then down at the bottom underneath that it says when Chloe went back to check the solution by substituting a value for x back into the original inequality, she found that something was wrong. Okay, so if he solves down and he gets x is greater than negative 6, what number could we use to check and see if he's true? Could you use negative 6? Should negative 6 make it true? I mean, honestly, you can use any value you want to. Should negative 6 make it true? Yeah. The answer is x is greater than negative 6. Should negative 6 make it true? I'm seeing some yeses and some nos. It should not make it true. Why? Yeah, Brandon?
Because x is only greater than negative 6. It's not greater than or equal to.
Okay, so since I don't have the equal to part on my sign, negative 6 would not work. Okay, could I use negative 7? I tricked you with that question.
No.
Is negative 7 bigger than negative 6?
Yeah. No.
No. Remember, in negative land, everything's opposite, right? So negative 7 is actually smaller than negative 6. So somebody give me a number that's easy to work with that's bigger than negative 6. Yeah. 6? Okay, that is okay, but I want one that's easier to work with. Luke?
1.
1 is a little bit easier. I want something that's even easier to work with than 1. 0. Okay, 0 is bigger than negative 6, and it's the easiest thing to work with. So let's test. So down on 7 it says confirm or disprove. So we're going to use 0 to check. So negative 2 times 0 minus 4 is greater than 8. Negative 2 times 0, that's why I like 0. Is negative 4 greater than 8? No, it's not. So we know he's wrong. So let's look back at his work. All right, so it looks like to get rid of the negative 4, he does an opposite operation of adding 4 to both sides. And then we have negative 2x, the 4's cancel here, 8 plus 4 is 12 here. We divide by negative 2 on both sides, and x is greater than negative 6. Does anybody see any issues with that? Isabel? Okay. So she said the inequality is supposed to be flipped the other way. Let's do a little test really quick. Okay? All right, so I want you to pick any two numbers and just write them over to the grid. I'll pick 6 and 10. You pick any two numbers you want to, because I don't want you to think this is all like set up. Okay, after you've picked your two numbers and wrote them over on the side in the grid, now I want you to put an inequality sign between them that makes it true. Okay, you got to make sure it makes it true, right? So in my case, I would say 6 is less than 10. You make your inequality sign however you want to. Okay, now what I want you to do is I want you to divide both of those numbers by negative 1 and just write them down underneath. So if I divide by negative 1, divide by negative 1, I have negative 6 and negative 10 now. So divide both of your numbers by a negative 1 and just write them down below. Now I want you to write an inequality sign that makes the second two numbers true. In my case, negative 6 is now bigger than negative 10. And I hope for all of you, your sign flipped. When you're multiplying it, remember, if I multiply by a negative on both sides, I'm changing everything, right? If I divide by a negative on both sides, I'm changing everything. I'm making everything exactly opposite from what it was. So the lesson here is if you ever multiply or divide by a negative number, you always have to flip your sign. That is the one special thing that's special about inequalities. Okay, if you multiply or divide by a negative number on both sides, you have to flip your inequality sign. Okay? All right, so let's flip to our last page here. I want you to do try these A, B, and C down at the bottom. So it said the heading is try these A. I want you to do A, B, and C down at the bottom together with your partners. Go ahead. All right, so A, I want to first get rid of my positive 3, so I would subtract 3 from both sides. And I have negative 4x is less than or equal to 8. Then I need to divide by negative 4 on both sides. That should start to be a trigger in your brain, dividing by a negative, especially when we're working with inequalities. That should start to become a trigger in your brain to tell you to do what again? Flip the sign, right? So it becomes greater than or equal to negative 2. So then graphing that, I stick negative 2 in the middle. One bigger would be negative 1. One smaller would be negative 3. And I have a couple decisions to make, right? I need to decide about the dot and I need to decide about the shading. So about the dot, should I have an open or a closed dot here? It's greater than or equal to. So what does that mean? Equal to means I take the value. So taking the value would be a closed dot. So I have a closed dot here at negative 2. And then x is greater than, bigger than, so I'm shading over to the right. Okay. All right, let's look at to B. All right, so I first need to distribute. So I have 6 minus 3x minus 6 is greater than 15. My 6 minus 6 cancels out, and I'm left with negative 3x is greater than 15. I divide by negative 3 on both sides, and again, dividing by a negative tells me to flip my sign. So x is now less than negative 5. So negative 5 is going to be in the middle. Negative 4 would be one bigger. Negative 6 would be one smaller. This time, am I taking the value or not? It's not equal to, so I'm not taking the value. So what kind of dot do I have? Open dot. So I'm going to have an open dot at negative 5. And x is smaller, so I'm shading back to the left for smaller. Always think about the alligator. Always think about which way you should shade. And then any questions on A or B? Okay, here's C. So I distribute into the parentheses. I have 2x plus 10 is less than, distribute on the other side, 8x minus 24. So I need variables to the same side. So opposite side, opposite operation. So I would subtract 2x from both sides. So I have 10 is less than 6x minus 24. If you didn't use the same steps as me, that's fine. I would add 24 to both sides. And I get 34 is less than 6x. Divide by 6 on both sides. And x, oh, I don't want to flip them here. X is greater than, it's 34 divided by 6. 5.6 repeating. Okay, 5.6 repeating. Okay, so this one's going to be a little tricky to graph. If you brought x's to the left side, yours will be a little bit easier to graph. You should have x's greater than 5.6. Okay, so to graph here, I'm okay if you put 5.6 as the number in the middle. I'm okay with that. If you just want to do like 5 here, 6 there, 4 here, that's fine. Again, I am not taking the value, so I would have an open dot at 5.6. Just get close if it's a decimal. And then is x bigger or smaller? X is bigger, right? Just don't just look and see, oh, this is a less than sign, so I'm shading less than. That's not quite true because my x is on the other side this time. X is bigger than 5.6, so I'm shading bigger over here to the right. Okay, do we have any questions? Alrighty.